Hello everyone, welcome back to our channel Startup Academy, where we focus on the ISS exam, and currently we are focusing on the ISS exam 2026. In the previous lectures, we have completed some of the major topics of statistics paper 3, which is of descriptive type, and in that we are covering the subject econometrics. So we have completed simple linear regression model, multiple linear regression model, and afterwards we have discussed some problems relating to these models, which is heteroscedasticity, autocorrelation, multicollinearity, and endogeneity. Today we will continue with endogeneity, and afterwards we will continue with autoregression model. Now, autoregression model is also a part of endogeneity, so we will start with autoregression model first. Autoregression model. Today's topic is auto. Now, when our variable or our error term are correlated with each other, then we use auto-covariance, auto-correlation method, which is a symbol of endogeneity. So, what are auto-regression model? Suppose we have yt is equals to beta naught plus beta 1 y t minus 1 plus epsilon t for all t goes from 1 to. Now this model here, we only have one kind of variable, which is y, and variable is only one kind, which is y. And here we will firstly find the OLS estimators, and then find the estimation of those estimators. So by following the method of OLS estimator, by OLS estimation, we will get beta naught cap as y bar minus x bar beta 1 cap, and beta 1 cap as summation ki yi, where I goes from 1 to n. Or we can also write t, whatever symbol you want to use in this. So here again in the OLS estimator, how we have calculated this? We have calculated this by taking e, which is nothing but equal to summation t goes from 1 to n epsilon t whole square, and epsilon t is nothing but summation t goes from 1 to n. Epsilon t is yt minus beta naught minus beta 1 yt minus 1 whole square. And on solving this, firstly we have to take the normal equations, which is again given by with respect to beta naught, and this with respect to beta 1 should be equal to 0. These two are normal equations. And on solving these normal equations, we will get what? Here we will get beta naught cap, which is nothing but y bar minus beta 1 cap x bar, and here we will get beta 1 cap, which is nothing but summation ki kt yt, or t goes from 1 to n. Here we can also write summation t goes from 1 to n x t minus x bar yt minus y bar upon summation t goes from 1 to n xt minus x bar whole square. This will be our final result. Now moving on further, if we have an MLR model, multiple linear regression model, if we have an MLR model which is given by y is equals to x beta plus epsilon. Here again we will use by GLS estimator, general linear estimation. For MLR model we will call the method as GLS estimation, and for SLR model we will call it as OLS estimation. By GLS estimation method. Now again we know that E is nothing but summation t goes from 1 to n epsilon t whole square, and here we can write epsilon dash epsilon, and epsilon dash epsilon is nothing but y minus x beta dash into y minus x beta. Now multiplying in dash we will get y dash minus beta dash x dash y minus x beta, y dash y minus 2 times of beta dash x dash y plus beta dash x dash x beta. This will be our value of E. Now again taking normal equation, here differentiating with respect to beta we will get 0 minus 2 beta x dash y plus 2 beta x dash x. Beta will get cancelled here, and putting this equals to 0 we will get our estimation, which is beta cap, which is nothing but x dash x inverse x dash y. So this was our auto regression model, and this is how we solve and find the estimation of auto regression model. Now here variance of beta cap will be nothing but, as we have calculated earlier, it is sigma square x dash x inverse. Now moving on to the another kind of model which is known as distributed lag model. Now auto regression model was also a lag model because there were two values of y given. Yt minus 1, which is the lag value of yt, and this is the slope, this is the intercept. So now we will discuss about distributed lag model. What is distributed lag model? Here we have two kinds of variable. X and y. Let us suppose you can take a or b or any variable. We are taking x and y. So let us suppose yt is equals to alpha naught plus alpha 1 x t minus 1 plus up till alpha p x t minus p plus epsilon t for all t goes from 1 to n. So this will be our distributed lag model, or we can change the variables here. we can write it as alpha naught plus with xt I am putting beta naught xt plus beta 1 xt minus 1 up till beta p if there are p variables xt minus p plus epsilon t. So this will be our distributed lag model. So where do we use distributed lag model? Suppose our y is GDP. Then X can be inflation. Suppose in Y we are calculating the job salary or salary. Then it depends on what? It depends on the experience or education of a person. So Y is dependent variable and X is independent variable as we already know. So this will be our distributed lag model. Now to solve this again, we can consider this model as y is equals to x beta plus epsilon, where y is where x. This is multiple linear regression model. We have concluded that these p values form are in this model. So beta, where beta is nothing but beta naught. Sorry, it should start with alpha naught, beta 1 up till beta. Now again by solving by GLS estimation method, general linear estimation method, general least square estimation method, we will get what? We will take E again, which is E dash E, epsilon dash epsilon, which is again y minus x beta dash into y minus x beta. And again on solving this, we will get beta cap or our estimation as x dash x inverse x dash y, and variance of beta cap x dash x inverse sigma square. We will get the same terms and hence we got our answer, or we have solved our distributed lag model. Now this was distributed lag model where our number of distributions was finite. Now we can the next part is infinite distributed lag model. This is infinite distributed lag model. Now here we have yt is equals to alpha naught plus beta naught xt plus beta 1 xt minus 1 plus up till we don't know where, or we can write infinity plus epsilon t for all t goes from 1 to n. Now this model can also be written as yt is equals to alpha naught plus beta naught xt. We can write it as summation I goes from 1 to infinity beta I 0 to infinity x t minus I plus epsilon t for all t goes from 1 to n. This model can also be written as summation of this term. So now, in this method, it has one limitation. what is the limitation? Limitation says that GLS or OLS method fails. In this, GLS or OLS method fail. If both these method fails or either of two method fails, then what will we do? So we have new approach which is known as Cauchy's approach to solve this method. To solve this model, we will apply Cauchy's approach. Now, what does Cauchy's approach says? So, Cauchy's approach basically says let beta k be equal to lambda beta naught, lambda ki power k, for all k goes from 0, 1, 2 up till wherever it goes. If we substitute the values of beta k in the model, our model is given as yt is equals to alpha naught plus beta naught xt plus beta 1 xt minus 1 plus beta 2 xt minus 2 plus up till epsilon t for all t goes from 1 to n. Now beta k can be written as lambda k into beta into beta naught. So substituting the value here, we will get yt is equals to alpha naught plus first one beta naught can be written as beta naught only, beta naught xt. Second one can be written as lambda beta naught xt minus 1. Third one can be written as lambda square beta naught xt minus 2 up to so on plus epsilon t. Let this be equation number 1. Now second equation we will take y t minus 1. Yt minus 1 can be written as lambda naught plus beta naught xt minus 1 plus beta 1 x t minus 1 t minus 2 plus beta 2 x t minus 3 up till epsilon t minus 1. Now multiplying this equation by lambda, we will get lambda y t minus 1 is equals to lambda alpha naught plus lambda beta naught x t minus 1 plus lambda beta 1 x t minus 2 plus lambda cube beta naught x t minus 3 plus up till epsilon t minus 1 into lambda. Let this be equation number 2. So we will subtract equation 1 minus equation 2. So this will become yt minus lambda yt minus 1 is equals to 1 minus lambda alpha naught plus lambda beta naught plus epsilon t minus lambda epsilon t minus 1 for all t goes from 1 to n. Let us consider this as yt star. Let us consider this as beta naught star. Let us consider this as beta 1 star, or let us say take simple considerations alpha naught star plus lambda beta naught plus epsilon t star for all t goes from 1 to n. This becomes our model. So now we will, now in this model we can apply our OLS estimator or estimation or GLS estimation. By GLS estimation, we will get beta naught cap, which is nothing but y bar star minus beta 1 beta, we can consider this as beta naught cap star, beta naught star x bar star, and we will get, let us take this on another page, beta 1 cap as summation t goes from 1 to n x t star minus x bar star y t star minus y bar star upon summation of t goes from 1 to n x t star minus x bar star whole square, where we know that alpha naught star is equals to 1 minus lambda alpha naught and yt star is equals to yt minus lambda yt minus 1, epsilon t star is equals to epsilon t minus lambda epsilon t minus 1, and beta naught star is equals to lambda beta naught. So this completes our Kochik approach, which is considered to be one of the most important topic in econometrics, and it has been asked multiple times in our previous year question papers. Now, one last topic is autoregressive distributed lag model. Here the model is again, here the model is taken between x and y both. So let us consider this yt is equals to alpha naught plus beta naught yt plus beta 1 yt minus 1 plus up till beta p yt minus p plus gamma naught xt plus gamma 1 xt minus 1 up till gamma q x t minus q plus epsilon t for all t goes from 1 to n. So here we have both variables of x and y, lag variables of x and y, and it is autoregressive. Autoregressive model is that the variable repeats itself. The variable has its own lag model, and here we have the variable's own lag model as well as another variable's lag model, which is distributed lag model. So this is the mixture of both of them. So this model can again be written as alpha naught plus summation I goes from 0 to p beta I y t minus I plus summation j goes from 0 to q gamma j x t minus j plus epsilon t for all t goes from 1 to n. This will be our yt. Now we have here epsilon t follows normal with mean and variance 0 and sigma square respectively. Now again we will apply GLS estimation method. We will consider this model as nothing but y is equals to x beta plus epsilon. Now here beta will be alpha naught, beta naught, beta 1 up till beta p, gamma naught up till gamma q. This whole will be beta. So here again by GLS estimation we will consider epsilon dash epsilon, and which is nothing but y minus x beta dash y minus x beta. And on solving this equation or the normal equation, we will get estimation of beta, which is beta cap, as x dash x inverse x dash y. And we will get the variance of beta cap as sigma square x dash x inverse. So this completes our topic of distributed lag models and autoregression models. We have completed autoregression model, distributed finitely distributed lag model, infinitely distributed lag model, and autoregression distributed lag model. So till now we have completed a major portion of econometrics. Let us see do what we completed. So this is the syllabus of econometrics. So econometrics, nature of econometrics, we have considered this in the first class. General linear model, which is again simple linear regression model, SLR. We have covered this as well. Its extensions, ordinary least square estimation, OLS estimation, we have been doing in almost every class, and prediction of the variable, that means it's estimation. Then generalized least square estimation, which is of MLR, multiple linear regression model, and its prediction also we have done. Now, heteroscedastic disturbances. We have already discussed what are heteroscedasticity and how it affects our model. So this also we have covered. Pure and mixed estimation. Pure and mixed estimation also we have covered, where we have discussed simple linear regression model and multiple linear regression model. Now, what is autocorrelation, its consequences and tests? We have done this as well. And multicollinearity problem and its implications and tool for handling the problem, and ridge regression. This also we have completed in our course. Then linear regression and stochastic regression. This the linear regression we have completed. Stochastic regression, as I have told you in every class, almost every class, that when a model is not when a model is deterministic, then it is mathematical model, and when a model is stochastic, then it is a statistical model. So till now, whatever models we have done are all stochastic regression models. Then instrumental variable technique, this we have done in yesterday's class also. Error in variance variables, this we did in today's class. Auto-regressive linear regression, lagged variables, distributed lagged variables, estimation of lag by OLS estimation, Kochik geometric lag model. All of these 4 5 topics we have completed in today's class. And we are only left with simultaneous linear equation model. From here, simultaneous linear equation model and its generalization, identification problem, restriction on structural parameters, rank and order conditions. All of this will be covered in one class. And estimation in simultaneous equation model, recursive 2 SLS estimation. 2 SLS estimations estimators we have done, and K class and 3 SLS estimation we will complete in the coming classes. So the almost the course syllabus is complete, and we will be starting from linear equation models from tomorrow. I hope you have understood what have we done in the class, and we are doing it syllabus by syllabus. And as you can see, I have covered almost all the topics of econometrics. I request you all to do all these topics along with me and solve their questions, PYQs along with me. Only then you will be able to get your doubts cleared. And if you still have any doubts, you can ask on our WhatsApp channel or in the comment box. Relevant doubts will be answered. Thank you.